Today's practicals is the fifth one, in which you will have to produce a map, your fifth map for your practical assessment. Okay, and then you will continue with a short mini project that which Dr. Rediano will brief you all on this. And today's prac is basically about spatial analysis. How are you able to perform simple spatial analysis by using the data layers or the data that you have? So basically, there's a different approach for raster datasets and vector datasets. So for raster datasets, I'm not going to cover it in today's prac, okay? But okay, I have provided some links for YouTube videos in which these videos show you all how to carry out raster type of analysis, such as reclassifying your raster datasets, the pixels, okay, reclassifying it from one old value to the other, okay, and raster calculators, overlays, and so on, how to use these tools that are provided in ArcGIS. Remember, always use online help. If you do not know which tool to use, search them in ArcGIS online help. You can use Google and see which tool is suitable for your analysis to achieve what you want to achieve. For the raster one, you have to it will be a bit of a learning process in order for you to achieve the results for the mini project. And for this vector one, I'm going to show you step by step on how to achieve it, and hopefully you all can do it on your own later on. Okay, so the data provided for this practical 5 is in the folder of practical 5. And as you can see here, okay, I've prepared 5 layers. 1, 2, 3 are point shape files. The site A, the second one, is a polyline shape file, and this one, Malaysia 2, is a polygon shape file. So we've learned this, and I've repeated this multiple times, that these icons will give you information of your dataset, vector dataset. Okay, and again, I want to say that these datasets, okay, were created purposely for your exercise, and it does not represent the real world scenario. Okay, so it's just fake dataset just for you all to practice. So the first task is displaying features based on their attributes. So how can you show your information? Let's say we have this cyclone A and cyclone A 1990. I'm going to put it in the table of contents. So I want to show the values of the attributes in different ways than what we normally do. Not only to change colors, but I want to change its symbols, its size, and so on. Okay, so the other layer is this. Okay, so I've given you the information of the layers. Okay, cyclone A shows the location of the eye, which is the center of the cyclone, at different times during the cyclone's lifespan. Okay, so if I remember how to see the whole layer, just right click. Okay, so my GIS is a bit slow today. Okay, remember, zoom to layer. If you find that your image is missing but you have it on the table of contents, just use right click and zoom to layer. Okay, and use these features to whether to zoom in or zoom out, pan to move it about like this. Okay, so yeah, okay, so as you can see, okay, the dots here represent the eye of the cyclone. So let's open the attribute table, and it says that Okay, how many points do we have? From 0 to 11, there's 12 points that make up this layer. Okay, what are the information provided? One is the category. Okay, 0 being the lowest category of cyclone. The higher the number means the stronger the strength of the cyclone. Okay, which is the maximum here is 3, and the speed is in another category of attribute because it's in the other column. So we have around 50 to about probably 79, the maximum. Okay, so we can display our data in various ways. So in your first task, okay, I want you to, it says here in your manual, okay, you are going to show your data cyclone A in categories. Okay, properties. So I would like to display the eye of the cyclone, the dots here, based on the level of category, which means as we saw in the attribute table, it's the minimum is 0 and the highest category is 3, means 3 represent the strongest cyclone, okay, for this layer. So because category provides attribute in terms of a number, okay, so it's quantitative. So click on quantities, okay, and then choose to create graduated symbols, okay, and the value here, select which attribute do you want to show. So I'm choosing category. Okay, so as you can see, this is the default symbol size selected based on the category of cyclone that we have in our attribute table. So it seems that we only have 4 values, so automatically it will give us 4 symbols. Okay, so this is easy. If we have 10 values, it will give us 10 symbols. But if we have more, we can break these values into classes, which means into range. That would be better. So instead of, let's say we have 100 values of 0 until 100, okay, we can break it into, like, let's say 0 to 10, one class, 11 to 21 class. So we need to define how many classes we want. So since it says here 4 classes, I will have 4 symbols representing 4 values of different cyclone category. Okay, so if I say 2 classes, okay, then it will give me something like this. Okay, it will divide my data, and we can divide our data, the values, into there are many options. Later we will see this. Just we'll do the most simple one first. So let's say I'm happy with the size of the symbol. If I'm not happy, I can double click and edit. But I'm not happy with the color. I want to change the color, so I click on template and I'm going to change it to red. Okay, click OK, apply. Okay, so now this is the layer that we have. This will show that it will give a better visual representation of our data set, showing that the largest symbol, okay, has the highest value, okay, because I've set the values and the symbols this way. Okay, so it's more clearer than the original form where we didn't change anything. Okay, this is how to show your attribute in a more better visual, a more creative way. So you can change the symbols into squares, diamonds, whatever. Go back to layer properties and you can change that. The colors, you can do so, but the positions will remain the same. Okay, and it will be easy for you to tell your viewers or readers that, okay, this location here has the strongest cyclone strength compared to the first and second dots on the right and the first dot on the left. Okay, so this is one way how you can show the values of attribute by using the graduated symbols, the size. So let's say you would want to retain the size of the symbols, okay, to be similar, okay, throughout whatever number it is. The only thing you want to change is color. We can you can go to Prac page 4, I think. Okay, we can do it the similar way, which is right click, go to layer properties. This time, okay, we're going to double click on categories. Instead of quantities, I'm going to use categories. Okay, so I am going to choose unique values, okay, which means all unique values will appear here. Okay, will be listed here, and all unique values will have a different symbol. Okay, so I'm going to select unique values, and the value field still remains the same as category. Okay, so click add all values to create the list of all the unique values for this attribute, and it shows that, okay, there's a total of 12 counts, and for the value of 0, which is category 0, there's 3 points showing 0. There's another 3 points showing category 1, 4 points showing category 2, and there's only 2 points with category 3. So as you can see here, okay, the only difference is the color. So you can change this color by choosing the color ramps here, okay, to show the lowest and the highest category, okay, or you can change it individually. And the size of these labels, okay, you can change them individually. If you think this is too small, you can change it as well by double click on this symbol and change it, even the color. Okay, so let's say we remain it as it is. Let's click apply and okay. So now this is what our map looks like. Okay, it shows different categories. So when you produce a map, you can have a legend, and the legend will show the different colors, meaning different level of storm category. So based on this two exercise, if you were to show storm category, meaning the 0 as the least powerful storm to the strongest storm, which has the value 3, which type of symbology will you use? Will you use this one or will you use the previous one? It's all up to you, but the main aim is uh, to visualize your results. So I think this is not really a good choice, because it's difficult for me to see where the strongest storms are, the cyclones are, and where are the least strongest. Okay, so as I said just now, that some data, it's because you have too many unique values, it will be kind of impossible or difficult if you were to display each unique values with its own symbol. Okay, so in this case, if you have data with many unique values or attributes that contain interval or ratio data, it is best if you display your data based on classification. Okay, so let's try. Right click in properties. This time we will try and show the other attribute for this layer, which is the speed of the cyclone. So the speed of the cyclone has more unique values than this category. So what we're going to do this time is click on quantities, and let's say we have graduated colors. Okay, again something like this, and choose This time, instead of a category, we choose speed, and let's specify how many classes we want, and click on classify. So this window will pop up, okay, classification, and in this we will choose, there's different type of classification that we can choose, okay, from manual, equal interval, and so on. Okay, so what options do we have and which one you want to choose? For this particular prac today, I want you to use equal interval. Okay, you can use others, and how to choose others is based on what you want to achieve. But basically, here today we're going to use equal intervals. Okay, so each intervals have the same number. Okay, same values or ratios, and click OK. So I've defined 5 classes here. You can define more, you can define less. Okay, and the labels, as you see here, the first interval is 50 to 56, 57 to 62. They are all about the same interval. Okay, and these are the colors of each intervals here. So click apply and OK. Okay, so here, if you were to create a map later on when you add on your legend, okay, you can see which color indicates the eye position of the cyclone, when the cyclone was moving the fastest, the slowest, and so on. Okay, so this, again, the fastest will be the darkest color as we've set here. Okay, and the slowest one is on the having the yellowish color. Okay, at the ends here. So these are just some examples on how you are able to show your attribute data in various ways. So it doesn't have to be the same symbol, same size, or the same color. You can play around with this symbology in order to better visualize what you want to tell the audience about your data. Okay. Okay, for the second part of the practical, okay, we're gonna see how to select information, or to do attribute query based on by location or by attribute. So I've provided some information, additional notes in the Prac manual for you to read on about Boolean logic, okay, and topological overlay, which this is a common or important thing to remember or to understand when you are carrying out spatial analysis. Okay, because each of the Boolean logic, okay, the processes, let me show you here. Okay, um, you have to understand what, because we're going to use SQL, okay, which is the tool to select information from attributes. Okay, for instance, where is that, what is there. Okay, so Boolean logic will help us to select which tool to use. Okay, so intersect, if we want to find um, spatial data that intersect or where they are both occur. Okay, I'll explain further as we go throughout the practical. We will use subtraction, okay, where only one occurs. If we have two data sets, let's say one still again for the same area, okay, one shows a seagrass location, okay, one data set is a polygon showing coral reefs, so they're both separated, one showing seagrass, one showing coral reef, and let's say we have another layer of point shape files showing locations of let's say jetties, okay, jetties. So um, if you want to ask questions such as where are the areas where we can find both coral reef and seagrass, then we will use the intersect tool for these two layers. If we want to say, okay, where are the areas of seagrass without coral reefs, then we will use subtract, okay, where only one of the feature occurs, which is the seagrass. I don't want where there's seagrass but there's coral reefs. No, I want where it's purely seagrass. Okay, and then there's a tool called union, where either one occurs, which is or. Areas that show seagrasses or coral reefs, which means whole area that comprises of these two features. And this one is, the other one is difference, okay, where either but not both occur. Okay, so we will use union without intersection, okay, a tool to get this information. Okay, um so please read more on this. There's many references on Boolean logic. Okay, and I've simplified the Boolean logic, or how to do spatial queries in a diagram as this one. Okay, where is that, what is there? Okay, and this is a question for attribute, this is a question for location. Okay, so how many questions? If you have only one question, you can use select by attribute. If there's more than one, how many data layers? If there's more than one, you will use overlay. If you only have one data layer but more than one question, you select by attribute again. Okay, and if it's select by location, how many data layers are involved? Let's say you have one, you can straight use the identify or select tool, okay, in ArcMap. So please find out what is identify tool, okay, what is select tool. And if there are more than one layers involved, okay, we can use select by location or overlay. Okay, so let's try. So I'll remove these layers. Okay, these are not going to be used, but this time I'm gonna include shipwrecks. Okay, I'm gonna include Malaysia. Okay, and I'm going to include lighthouse. I'm gonna put lighthouse. Okay, so why should this layer lighthouse be on top of Malaysia? So remember, okay, that the position of the layers will determine how your data will look at the final output, or how you can see your data here. Okay, so since lighthouse is point shape file and Malaysia is a polygon, okay, and it's not hollow, it has a color, which means everything underneath will be covered by Malaysia. So the best thing is to drag this one and put it on the top. Okay, if I can't do that, do this first. Okay, put it on top, click this back here. All right, just switch between these two, okay, to move your layers. So, and as you can see, I can't differentiate which one is shipwreck, which one is lighthouse. So I think I'm just going to change the symbology for lighthouse so it's easy for me to see it. Okay, so now as you can see, I can see the placement of the lighthouse. So the shipwrecks, okay, shows the location of ships that sank along the coastal area on North Sabah. So basically, this is just a creation. I just created this data. So the lighthouse is the lighthouse. I hope you all know what lighthouse is. Okay, so it's very important for sea navigation, so that the ships do not crash to shore, on shore, and so on. And Malaysia is just basically the shapefile for Malaysia. Okay, if I want to see the whole Malaysia, I've extracted it from the world shapefile. I'm going to zoom to layer. So this is what it looks like originally. Okay, but since I just want to see the shipwrecks and the lighthouse, I'm just going to zoom on shipwrecks, zoom to layer. Okay, so it will show the whole shipwrecks. Okay, so I know that the blue dots are shipwrecks. Let's see what the attributes are. Okay, so how many attributes that we have here? First, it says shows that it's all point. This is the ship name, so we have ship names here. Okay, you can go through it. Year sank. Okay, when did the ship sank or shipwreck occurred? Okay, and was there fire? Yes or no? Y means yes. No means there were no fire during the incident or the accident. And how many deaths, how many people died on board during the shipwreck. So I created this data set here, and there's 0 up to, I don't know, I think 12 the maximum probably. And poor vis means whether there were poor visibility. Okay, some sort of poor visibility occurred during the accident or the shipwreck incident. Okay, Y means yes, N means no. Okay, so this data set I created purposely for your exercise. You can sort your data set according to ascending or descending numbers and alphabet. So it's up to you. So for now, I'm just going to leave it this way. So I'm going to close it. So what are your tasks? Let's see. So based on the information that you have, the 3 layers, you are asked first, the task 1, how many ships sank along the coastal area before the year 1900? The second question, how many ships that were on fire at the time they sank and had more than 3 people died? So on page 7, task 1, let's do this first. How many ships sank along the coastal area before the year 1900? So let's open. So here's the date, the year where the ship sank, and we want ships that sank before 1900. So what are we supposed to do? We can select by one, okay, but it will take it's tedious, it's going to be tedious, and we might make mistakes, and it will take a longer time. Okay, so what we need to do, just close this, and then there's a tool here, says select by attributes. Okay, if you forget, okay, let's just move. If you forget, there you can use the search tool. Okay, behind here, let's see, search tool, this one. Okay, and type in the tool that you think is the one that you want to use. Okay, so if you know what tool you want to use after doing some research and googling, you can type the name of the tool here. And because today's task, I know what tool to use, it's over here, is select by attribute. I'm not going to use the search toolbox, but you can use this one. It will give you information on anything and will guide you in any of your spatial analysis project. Okay, so I'm going to close this one. Selection, select by attribute. So the task is to select ships that sank before 1900. So here are the attributes that were captured from the attribute table. Okay, ship name, year sank, and so on. So obviously we need to choose year sank. Okay, so double click on this. Okay, and what do we want to find? Okay, we want to find the ship that sank along the coastal area before the year 1900. So before means this one. We want to get ships that has a value smaller than 1900. Okay, let's verify. Okay, let's apply and close. So it shows that, okay, the blue ones that are highlighted are the ships that sank before the year 1900. Okay, so let's use this identify tool and just click on any of it. Okay, so let's see. Okay, so it says that year sank is 1766. The ship name is Oblak. Okay, so this is true. This is before 1900. So let's look at this one. It says that the ship name Silva sank in 1793. This is true as well. So based on this equation that we chose just now, select by attributes, okay, and we use this called the SQL, okay, the formula used for GIS to obtain information or to select information from our data set. Okay, so let's open here the attribute table. So as you see, okay, all these blue rows are highlighted. Why? Because all of these points fulfill the criteria that we wanted, which is sank before 1900. So how many ships sank along the coastal area before the year 1900? You can find the information down here. 32 out of 40 ships. So 32 ships sank before the year 1900. Okay, so if we were to create, this is just selecting. It doesn't create a new layer showing ships that sank before 1900. But if we were to create a new layer of ships that sank before 1900, what we need to do is right click, okay, on this original layer, okay, right click, data, export data. Okay, so when we export data, it says here the option is not all features but selected features. The ones that we selected using the selection tool here, select by attribute, the ones that are highlighted in blue, okay, only these data will be exported as a new layer. So we've done this before in our previous Prac. Again, browse to the folder that we want to save this new layer, give it a name, okay, and export. But I'm not going to do it today because I don't need to do it. Okay, so I'm just going to cancel this and then I'm just going to close. But remember, okay, after doing all of this, click on clear selected features. Okay, so which means no features are now selected. Okay, and we can continue with the second task. Second task, how many ships that were on fire at the time they sank and had more than 3 people died? So two attributes. Okay, so let's see. So the second task is to find how many ships that were on fire at the time they sank. So fire equals to Y, and had more than 3 people died, so which means death more than 3. So it will be kind of difficult if you were to do this manually. So what we can do is use this search tool again to find our information, or what we can do is we can use the um, select by attribute, since we are only using one layer and we're selecting several attributes. So again, we can use select by attributes, but this time I'm going to teach you all how to use the arc toolbox. Okay, we use models so that we can trace back our work or our spatial analysis. So I'm just gonna remove this one first because I did this before. Sorry. So how you're gonna add toolbox is right click, okay, new, and then select toolbox. Once you have that, okay, sorry, under toolbox, right click, okay, new, and add model. So this will pop up. Okay, when you want to open it, do not click open, click edit. Okay, this empty window will come up, and what did we want to do? We want to use select by attribute. So we can find the select tool here. So you can see there are several options of select, and I know that we're going to use select analysis tool. And how do you know? You can click on this. It will give you the information about this tool. Okay, so let's wait a bit. So this window will pop up. It will tell you what select analysis tool is. It extracts features from an input feature class or input feature layer using a select or structured query language, or we call it SQL expression, and stores them in an output feature class. Okay, so these are more information and you can Google it and so on. So since I want to use, where's my tool? This tool, and I wanna, where's my model? It's not showing up. Let's hold on. The model needs to be here somewhere. Let's see where it is. Oh, it's here. Okay. So again, search. I want this tool. So what do I need to do is I'm gonna click once. Left click once, and I drag it to my model builder. Okay. So this frame, okay, shows that I've selected this tool. Okay, and I'm gonna close this one. So select your input would be, double click on it. Okay, input features. Okay, when we double click on this select, it will, this window will pop up. So the input will be again shipwrecks. Okay, shipwrecks. Okay, these layers appear here because they appear in table of content. So automatically the select tool gives you the option in the drop down, okay, to select which of these layers. Okay, if they are not here, then you are not able to select them in the drop down symbol here. So my input features is shipwrecks. My output, okay, again, browse to your folder. So I should name it as ship and what, fire, and 3 people died. Ship, fire, and I'm just going to put number 3, since I know that 3 means 3 died, or maybe a 3D. So make sure the names that you put for your layers, you are able to trace them back to what analysis did you do. Okay, I'm just going to save it. And then before you click OK, click on this SQL button here. Okay, so we're going to do the query builder. It's similar to what we did in selection here. Okay, so again, select the ship that was on fire. So double click on fire as one of the attribute, and get unique values. So it's either N or Y. So what we wanted was yes, fire. Double click on yes, and remember, and had more than 3 people died. So there's an operand here, easy for you all to use. And I'm just going to click and what was the other attribute? People died in deaths. Select deaths and get unique value. So what was it? More than 3 people. So more, you can type this manually or just use click more. You can type it manually or you can select 3 from here. More than 3, or you can type it. So double click on 3 and click verify to see if your expression is successful. Yes, and click OK. And then you click apply and you click OK. Okay, so once this, we have this, okay, then you will have to wait for the processing or you run. Okay, the model. Okay, so now we have a new layer, Shipfire 3D. Let's see, it should appear here. Right click, refresh. Okay, so it's not here. So right click, add to display. Okay, so let's click on this. So let's open the attribute table. It says that there are 9 ships that caught fire when it sank and had more than 3 people died on it. As you can see, there's no value below than 3. So we did this based on the select tool, and we performed, okay, the model builder here, and so on. So there are ways to label this, okay, and we can do it easily. So we create labels, so we can type, okay, so that we remember what we did. So okay, just okay, what's the label? We can put it on the bottom or on the top. So what was this? This one is fire equals to yes, and, or we can use multiply is a symbol for and, death more than 3. So this is the label for our first model. Okay, so as we go on, we can save the steps, the spatial analysis that we conducted, so we know what we did and what this layer is all about. But you have to make sure you follow the labels and use the correct tools and so on. So I'm going to save the model. Okay, save as, I'm just going to put Prac5. Okay, save. Okay, so the third task is similar, which is how many ships that sank when visibility was poor. Means in the attribute table, there's a column for poor vis, means poor visibility, and it has to equal to y, yes, and where at least one people died. Okay, so at least one people died. Let's see how we can do that. Again, I'm going to use, because this is just from one layer, I'm just going to use the select tool again. Okay, and drag it here. Okay, and double click on this select tool. Again, the input feature will be shipwrecks. Okay, or what does this blue means? This blue colored layer is the same thing as this one, except that this layer is already present in your model builder. Okay, so if I were to select this one, there will be an arrow connecting this blue shape, okay, to this square kind of rectangular shape here. So I'm just gonna, sorry, I'm gonna use shipwrecks, okay, the blue one, and where will I put this? I will rename it this one, poor vis and depth 0. Okay, so poor vis depth 0D. Okay, so I'm just gonna save it. And what is the SQL? So poor visibility, let's find the attribute for poor visibility. Double click. Okay, get unit values. What did we want? Equals to y, equals to y. Double click on y. And okay, where at least one people died. So I'm going to use the operand and. So if it's or, you can use or, you can use not based on your task. But today it's going to be easy. I'm just going to use and. And at least one people died. So let's find the attribute for deaths. Double click. Okay, so what should be the operand here? So at least, which means not equal to 0. So I'm gonna choose this operand, okay, and use click type in 0, which means please select me, okay, the ships that has poor visibility, and at least one people died, means that some sort of death occurred. Okay, any values. So this is the expression. So let's verify the expression was successful. Click OK, and I'm going to click OK and apply and OK. Okay, so I'm going to run this model. Okay, close. And as you can see, there's a new layer here of poor visibility with 0 death. Means more than at least one person died, okay, where death occurred. So I'm going to show it, display, add to display, okay. So I'm going to save this as I go on, minimize this. So let's uncheck this. So this new layer shows that the ships that sank when visibility was poor, okay, we couldn't see anything, maybe it was fog or something, and at least one person died. At least one person, which means more than zero. Okay, so let's open the attribute table and check and cross check. So poor visibility, as you can see, yes, only Y was selected, and then death, no zero values here. So these are the ships. How many? 16 ships fulfill the criteria that we wanted. Okay, hopefully you can understand this by now. Okay, let's continue with the fourth task. Okay, it says how many ships sank near land less than 5 kilometers from the shoreline. Okay, so there's a tool that we can use, okay, to identify the areas beyond the boundary at a certain length or distance. What we call it buffer. Okay, so there's a buffer tool that I kind of like, okay, because it will give you the distance based on a feature. Let's say you have a river, okay, one line, and you say create me a buffer of 550 meters left and right for this river. It will create a buffer zone for you. Okay, so this is the buffer analysis tool. Let's see. Okay, so this is what I mean by buffer analysis, the tool that can help you, okay, find a buffer zone, an area equal to the distance that you've selected. Okay, for points, your buffer will look like this. For lines, this is example, it will look like this, and polygons, it will look like this. Okay, and if you dissolve it, there will be only like one whole polygon. Okay, so you can read this more, and this is kind of useful. Okay, so what I'm gonna do again, I'm gonna use the buffer tool. Okay, I've selected buffer here. Okay, I know that I'm using this tool, that's why I can drag it here. And which layer should I use? It says that ships that sank near land. Okay, which means first we are using two layers here. First, we need to create a buffer of less than 5 kilometers along the shoreline, and later we need to intersect it with another layer that shows the locations of ships. Okay, so the first task is to create a buffer, okay, for what was it, near land. So I'm going to use buffer, double click. So input features will be Malaysia. Okay, that's the land. Okay, output feature will be, I'm gonna just name it Malaysia 50. How is it 50? 5 kilometers. Malaysia 5. Okay. Save. And linear unit, because I said kilometers. Okay. So the linear unit is 5. Remember, your data set has to be has a projected spatial coordinate if we were to do this. If it's a geographic coordinate, it will be difficult to perform this buffer feature. Okay, so what else? I'm just going to leave it as default. Okay, and then click apply. Okay, I'm happy. Okay, 5 kilometers around shoreline of Malaysia, and then I'm going to click OK. So I'm going to click run. Then close. So I'm going to add the new layer, okay, to display. So what I have now is a buffer zone, okay, 5 kilometers, okay, around the shoreline. So because it's larger than this one, the original Malaysia line buff polygon is covered. So this is the original Malaysia boundary. So this is a new one which has the buffer. Okay, 5 kilometers from the shoreline. So if we were to zoom in layer, let's say zoom in layer. Okay, so this will be the buffer zone for the whole Malaysia, but since I'm just looking at this part, so go back to shipwrecks and zoom to layer. Okay, so based on this, we actually can count how many shipwrecks are within the buffer layer, a buffer zone, which is shipwrecks that ships that sank near land, which is 5 kilometers from the shoreline. So it's this, all those in the pink. Okay, these is, but it will be tedious to count manually. So there's another way to conduct this. We have a new layer, Malaysia 5, and the other layer is shipwrecks. Okay, so the tool that we're going to use is, so the tool that we need to use for this task number 4 is intersect. First, we have this polygon showing the buffer zone 5 kilometers from shore, and we have the layer of shipwrecks. Okay, so what we're going to do is we're going to use the tool intersect. Okay, so what does intersect means? Okay, it this tool will provide computes a geometric intersection of the input features. Okay, so features or portions which overlap in all layers will be written to the output. Okay, so we have the buffer zone. Okay, and we have the shipwrecks location as points. So we want those that fulfill both criteria, intersect, which means the operand and. Okay, so go back, intersect. Okay, and double click on intersect. Okay, so input features. What features do we want to put inside intersect? Don't select the correct ones. We have Malaysia 2, Malaysia 5, so I know it's Malaysia 5, so it's here. So I'm going to use Malaysia 5 as the first layer and shipwrecks as the second layer. So the intersect between both of these layers will give me the information that I wanted. Ships that sank near land, which is less than 5 kilometers from the shoreline. Okay. Output feature, give it a name. I'm going to put here ships land 5 cam. See if this is accepted. All right. Leave it on default. Click apply, click OK. Okay, so this shows that we have Malaysia 5 as a layer, shipwrecks as a layer. Those that intersect, okay, is provided in the new layer. Completed, close. So right click, add to display. Let's save this as I go. All right, so what you have now, okay, let's uncheck shipwrecks. So we have shipwrecks that sank, ships that sank near the land. All of these. So how many of them? Put an attribute table. So there's 22 ships that sank. Okay, sorry. Okay, that sank. Okay, 22 ships that sank. Okay, near land. So these are the details of the ships. Okay, ship names, here sank, and so on. Okay, so these are the new layer that provides us the information that we wanted. So the final task is how many ships sank near the lighthouse. And I've given you here less than 10 kilometers. So the buffer should be 10 kilometers. So where are the lighthouses? It's the green one here. So again, we're going to use the tool buffer. So there's 2 steps. First, you're going to use the buffer one, and then you use intersect as well. So buffer, we knew that this was the tool. Just drag it here. Okay, so I'm going to just sort this one first. Okay, buffer here. Double click on buffer. Which one do we want to create a buffer zone? So the input feature is the lighthouse. Okay. Okay. So what should we name the new layer, the output? So lighthouse, let's say just put L house buffer 10 km. So I know that this is the buffer zone. Save. So it will be again in kilometers, and we've selected 10. Okay. Apply and click OK. Run. Close. Okay. All right. And then the new layer, add to display. So this is our new layer. This purple one is the buffer zone that we created for the lighthouse. The buffer zone, which is 10 kilometers around the lighthouse. Okay. So you can see. Okay. So this is the buffer zone. Okay. We decided on the 10 kilometers, and we said we want a buffer zone around this point. So ArcGIS creates this buffer zone for us. You can change the color as we go later. So now what is the second, to answer this, how many ships sank near the lighthouses? Again, it's a similar process. We use the buffer zone, okay, lighthouse buffer zone, and we're going to use the intersect tool. Yeah. Okay. So the two layers that we're going to use to intersect is the lighthouse, okay, and the lighthouse buffer and the shipwrecks. Okay, so I'm going to use intersect again. Intersect and misses. Okay, so I'm going to drag it here. Okay, double click on intersect. Okay, what are the input features? The input features will be the lighthouse buffer, which is the 10 kilometers buffer, and the other one is shipwrecks. So I'm going to use the yellow one, so a separate layer. Okay, so output would be ship lighthouse 10. Okay, apply. Okay, where is it now? Okay, run. Close. Okay, so the new layer, add to display, save this one. So how many ships that sank near lighthouses with the within the 10 kilometers from lighthouses? So easily we can see here there are just a few, but let's click on the attribute table. There are 7 ships that sank within 10 kilometers from the lighthouse. These are the ships, the year they sank, and the other information. Okay, so this is how you do the simple vector analysis in GIS. Okay, so this is just a practice on how you use models. Okay, so that you can trace back your work. Okay, and you can change the layers as you go. Okay, but it's enough at this level for you to understand the basic of this. So after this, okay, what we've learned, I hope that you are able to use the more simple tools available for vector analysis. And then there's the SQL, okay, how to select by attribute, okay, and the assessment for practical 5 is you need to produce a map showing the locations of shipwrecks that occurred for this region, basically from my data sets. Okay, show the label, show or and label the ships that sank 15 kilometers from the lighthouses. We did 10 kilometers, so just have to repeat my steps. Color the symbols red, color the ships red, okay, and include the lighthouses in your map. So in your legend, you can have the ships that sank within 15 kilometers from the lighthouses. Then you have the lighthouses, okay, and you have to show the buffer zone of 15 kilometers around the lighthouse, similar to what I did just now. Okay, this is the buffer zone. You will have a larger circle, okay, basically. And again, create an effective map, make it use proper colors and whatnot, symbols, fonts, legends, okay. So that would be the practical 5. And for the raster analysis, database query for raster, please watch the YouTubes. And as you get the instructions for the mini project, you will see, or you will learn how to use the tools for raster. For today, we've learned tools for the vectors. So basically, from this YouTube and other resources, you will need to show what tools are you using to analyze your raster data to achieve the objectives of your mini projects. I think, I'm not sure, is there 5 maps you need to produce, and since it's a group work, I think it's going to be faster, and we're only asking you to use the most simple tools. So you have to discuss and decide the approach of your project, the mini project, either using the vector approach or using the raster approach, because we learned that we can always convert one type of feature to the other. But again, there's pro and cons using these conversions. So you might have to use these tools as you go along. Okay, so if you have anything, you can ask me. I think I'm gonna let you know when I'll be online. If I don't have a meeting, I'll be available for any online discussion. If you find problems doing this practical 5, it shouldn't be a problem because I've shown you through the video. So it's a 1 hour video. So I hope you can produce a great map after this, and good luck.